Oxidation of alcohols. So if there is oxidation, there should be reduction as well, right? But how does it work with organic compounds? We need to look at redox reactions and from a new light, actually an easier way to look at redox reaction. So reduction and oxidation can both be defined in terms of the transfer of electrons that we already know, right? So for example, oxidation is losing electrons and increasing oxidation number. However, for organic compounds, it's very hard for us to actually identify losing electrons because they're all about breaking covalent bonds and forming new ones. And also, it's very hard to assign oxidation number, especially for carbon atoms, given that they are bonded to atoms of different kinds of electronegativity. Okay? So, in organic reactions, we want to look at oxidation in a more observable manner by looking at if this compound is gaining oxygen or if this compound is losing hydrogen. So if something, an organic compound, is gaining oxygen or losing hydrogen, then it is being oxidized. Okay? It is going through oxidation. On the other hand, if it is losing oxygen or gaining hydrogen or gaining hydrogen, then it is being reduced. Okay? So, and people are thinking about, okay, so alkene going through addition reaction to become alkane, is that a reduction reaction? Yes, it is reduction reaction because it's gaining hydrogen atoms, right? If you add a hydrogen molecule into a alkene to turn it into alkane, that alkene is being reduced to alkane. Okay? So oxidation of alcohols is the one that we really need to know. So we normally use a acidified dichromate or acidified permanganate as oxidant, that's oxidizing agent. They are the one that's going to shove oxygen into the alcohols, or basically taking the hydrogens away from the alcohols. Okay? Different alcohols will react differently. So, and the products will be different for different types of alcohols. Primary alcohols normally end up with CH2OH. Then they will first be turned into aldehyde. You see that the end of the hydrocarbon chain that was functional groups is losing two hydrogens. And afterwards, if you keep oxidizing it, then it will then accept another oxygen to become carboxylic acid. Okay. Secondary alcohols is sort of stopped in the second step, in the first step, sorry. So because it's in the middle of the chain, it only has one hydrogen on the carbon. The oxygen is also attached to only just one extra hydrogen. So in the end, that hydrogen will go, that hydrogen will also go, then you end up with a carbon-oxygen double bond. So here the carbon is bonded to, again, two other alkyl groups, and it's double bonded to the oxygen. Okay. That's ketone. Okay. Tertiary alcohols, they are resistant to oxidation by these two commonly used oxidants, so inorganic oxidants. And in VCE, we don't really talk about that. Okay. So oxidation of primary alcohols, the general equation looks like this. You have the end of the chain being acidified dichromate being oxidized to aldehyde first, and then going to carboxylic acid. It can go straight if you have really higher temperature and basically higher concentration of dichromate. If you want the aldehyde in the middle, then you need milder conditions, lower temperature, and use a shorter reaction time. So it's sort of like if you want the middle product, you cook it for less amount of time and at a lower temperature. A oxidation of secondary alcohols turns all the secondary alcohols into ketones. You can use, again, acidified dichromate or acidified permanganate.